Next topic is Hibernate Mapping. So there are two different kinds of mapping. One is cardinality relationship mapping. That is reflecting one-to-one, one-to-many, and many-to-many relationship. And the second type of relationship is inheritance relationship, where one Java class is a parent class of another Java class. Okay, and in that case, how you are going to construct a table from that inheritance relationship, you have a choice. Okay, so there are in fact three different choices. So we're going to look into each of those in a bit more detail. So mapping cardinality relationship. So as I said, it could be one-to-one and it could be one-to-many. One-to-many is the other side is going to be many-to-one. Okay, so you can consider both to be the same. And then many-to-many. So one-to-one relationship expresses a relationship between two classes where each instance of the first class is related to a single instance of the second class, meaning there is only one instance of each. Okay, and when you reflect this one-to-one relationship in database tables, you have two different ways of doing it. One is using foreign key constraint in one table, reflecting the ID of another table. That's more common scheme. And another way you can do is actually using same primary key values in each of those two tables, but this is rarely used. Moving forward, so one-to-one is not that much interesting. So what is the most popular cardinality relationship is one-to-many. So in Hibernate, in Java, you can actually use a different set of collection classes to reflect this one-to-many. So you can use set, you can use list, and you can use array. And so as you have, as you probably know, set is there is no duplicate allowed, and it doesn't have any order, right? But when you're using list, it could have a duplication, but it has an order, which means that it could actually use index. And same thing with array. And then Hibernate also provides another scheme called the back, and in this case duplicate is allowed and it doesn't have any order. So this is the probably the most wide spectrum, the largest, let's say, the set of the items, I would say. All right, so let's look into using set. Okay, so this is one-to-many case using set. So we're going to look into each of these four cases. So we're going to look into the usage of set in the case of Java, and then we are using in the configuration file you're going to use a set element. Okay, so let's take a look at that example here. So in this case, we are going to reflect one-to-many relationship between an event and speakers. So an event can have many speakers. So that's the reason there is a one-to-many relationship between event and speaker. So in the mapping file of, in this case, event class, you are going to specify event and ID and property, so nothing new. But here, you also specify the relationship. Okay, so here you are going to use your set and the name of the speakers. This is a speakers, and then the key column is event ID. So this is the foreign key column in the child table, in this case speaker table. And then you say one-to-many class, the relationship class is the speaker. Okay, so you're basically having these four lines indicating one-to-many relationship between event and speaker. As far as the speaker is concerned, there is no the special setting required, okay? Because the event class setting already specify one-to-many. There is nothing you have to do in speaker mapping file. And in terms of coding, so inside of your event class, you are going to have a set of speakers. Okay, so private set speakers, and this is in fact the same. This field is reflected here. Okay, so the speakers has to be the same as the property value in your Java class. Okay, so event class has speakers property. Okay, so that is this guy. Okay, and in terms of coding, here we are creating event object, and we set the name of the event, and then we are creating set object. So we are using hash set implementation of set interface. So then we are adding 3 new speakers to the hash set object. Okay, and then when we call save or update, so when we actually call save or update or save event, it will actually save the not only event table but also all the speakers. The reason is because we actually use what is called cascading, cascading all. So we're going to talk about this cascading attribute later on. So when you say cascade all, in this case, what it means is that whenever you are saving or deleting event object, all the speaker objects that belong to this event object will be also saved or deleted. Okay, so if you don't say cascade attribute, that means it's your responsibility to make sure the speaker, you actually save speaker object yourself. Okay, and that's a little bit of work on your side. So instead, you typically use cascade the attribute to indicate that whenever event object is saved or deleted, you want the speakers object that belong to that event also saved or deleted. Okay, so that is basically this code. So we just save event object, and all the speakers will be also saved, meaning there will be 3 entries to the speaker table. Okay, all right. So when you do this, the tables that reflect, so speaker is actually the one that has the foreign key column, so that is the event ID, and that is actually what is specified right here, key column. So that is, if you change this value, so in the exercise you can just change this value and see what happens. So in the exercise, try to change things around, see whether things are working fine. Make a change to speakers instead of speakers, say speakers 1, without changing Java code, and see what kind of the problem that you experience. Okay, and try to cascading, delete this cascading and see what happens. Okay, so that is that. Okay, so that is set. And the rest of the presentation is pretty much the same. So in this case, you're using list. Now, the only difference in this case is, the list has an order, okay, which means that is in fact what is called the index column. Okay, so you can specify index column index IDX. This is the name of the column that you want to actually specify. Okay, and this is name of the stories. So this is a group class, should have a stories, the property. Okay, and rest of, so the only difference in this case is index column, because a list can have an order. Okay, so in this case, again story, there is nothing special setting you have to do, and so here you are using list interface, and here we create array list object, and we are adding 3 stories to that the list, and then we have group singers, and then we set the stories list, this list of the stories by calling set stories, and same thing with the second array list. And then in this case, when you actually display the table, you not only have the foreign key column parent ID, but also you have index column, which represent an order in these 3 items. And again, we have 2 items, so these are providing order of these entries. Okay, so that is a list. Array is pretty much the same as the list because it has an order. So again, you have index column, okay, and the rest of it is pretty much the same. Okay, so there is nothing you have to do on story. And here, instead of list or set, you are going to specify an array of story. Okay, and here we are actually adding 2 stories using array object. Okay, and again, the table should have this index column. Okay, so it works pretty much the same as list. Okay, the last one is a bag. So bag is a little bit special in the sense that using bag for association mapping, the domain object in the collection could be duplicate. So you know, it could be actually non-set, okay, and without order. Okay, so this is most general. I mean, that's the terminology I was actually looking for. Most general form of mapping. So here we can say map, and then stories, and then key column is parent ID, and one-to-many class is story. Okay, so in this case, you know, we can use either list or set or whatever. Or actually, probably list. You know, the set itself is actually not allowing any duplication, right? So you might want to, in fact, use a list in this case. Okay, and then you are going to create the objects and save it. And here, because there is no index involved, so you know, basically, only thing it has is actually a foreign key column. All right, so let's do exercise 1. Let's take a look at the exercise 1. So exercise 1 is one-to-many relationship. So here we are going to try, yeah, so you know, we are trying set, list, array, and bag. Okay, so basically when you are running Hibernate one-to-many mapping set, so in this case we have events and speakers. So event is the one side of it, and the speakers as many side of it. Okay, and the foreign key is always in the many side of it. So here the foreign key event ID, basically this person speaks in event 1, and event 1 Bill Clinton is also speaking event 1, and Sang is also speaking event 1, but Daniel and James they are speaking event 2. Okay, and if you take a look at the code, you know, again, saving an event object will also save speaker object because we use a cascading. Okay, so if you have to take a look at the configuration file, we are basically using cascading all. Okay, and this is the foreign key column. This is the class that has a one-to-many relationship between this event class. Okay, and so you know, and then we have 4 different mapping files. Okay, so I'm gonna just run this code, set, and run the application. Okay, and this is what you should actually see. Okay, and rest of the code is pretty much what I explained in the presentation. So I'm not gonna actually spend time on it. And again, I recommend you guys to play around with it. You know, make some changes and see how things blow up, and you know, things like that. Okay, so I'll give you guys about 15 minutes to try these exercises. Okay. All right. Next relationship is many-to-many relationship. So here we are going to have a many-to-many relationship between speaker and events. Okay, so a speaker speaks in many events, and an event can have many speakers. Okay, so you are going to have the mapping file on both classes. So this is the event mapping file. So here everything is as expected, and then here we have to specify set. We are going to use a set and a name. So this is the name of the property inside this event many class, and this is the name of the table. By the way, so this table is what is called the join table. So when you are building many-to-many relationship, you cannot use a foreign key. Okay, you are going to use a join table. Okay, so the name of the join table is event and speakers. And now here the key column is event ID, and many-to-many column is speaker ID. So this this table will have an event ID and speaker ID. Okay, and the speaker class should have the same similar mapping file. Okay, so it has the events properties reflecting events. Then the name of the table is the same, events speakers. Here speaker ID and event ID. Okay, and in the code you are going to have, this is event class. So event class has a speakers, speakers property with a set. Okay, and we have a set and getter method. Same thing for the speaker, class. So it does have a set of events, and we have a getters and setters of that events. And in terms of building up the object, so here we are going to create event first, and then we set the name of the event, Java 1 conference. And then in terms of speakers, we are going to use a hash set, and then we are adding 3 speakers to that event. Okay, so this is the first event, and the second event. Second event is called the Passion conference. And in this case, Sang is also speaking in Passion conference. So Sang is speaking in Java 1 conference and Passion conference. But Shirley and Diane, they are speaking only in second conference. Okay. So if you run the code, what you're going to see is this is event table, and this is a speaker table, and this is a join table. Okay. And you can see some of the duplication is because we have not reset the reverse direction thing. We're going to talk about that in JPA using annotation. Okay, so for now, just accept the fact that we are not completely done using that reverse direction thing. All right, so let's do exercise 2. So if you run exercise 2. That is many-to-many cascade and load. Okay, so if you run the code, and so we have a join table, and we have events table and speaker table. Okay. You can see join table doesn't have its own primary key field because the combination of these two provides the primary key. So there is no primary key column needed in the join table. So that is, let's see, that is exercise 2. So yeah, so that's basically exercise 2. So I'm gonna give you guys about the 7 minutes to try exercise 2. Okay. Next is mapping cardinality relationship using map. Okay, so you can actually use the map. So in this case, we have the support property has setup property. So this is the name of the class, and this is the name of the properties, name of the property inside the support property class. Okay, and here we are using map element, and the map element could have an index. Okay, so this is the property name and string, and the element is property value. So this is a kind of key value pair in a sense. Okay, so here we have map property, properties map, so it should have a key value pairs, right? Okay, so here we created a support property class, and then we have hash map, and hash map has a key value pair. So we have 2 key value pair values. One is the car and Ford, and house is Lexington, and we set the set properties and we save. Okay, so you could use the map as one of the relationship. So in this case, we have a properties which has a property value, property name, and property value. Okay. All right. So exercise 3. I'm gonna give you guys 5 minutes to try the few minutes to try the hash map. That is exercise 3. Okay. So just run the application, and this is what we are going to see. And the code is pretty much what I've shown to you. Okay. All right, so I'll give you guys a few minutes, and let's have 10 minutes break. So I'll give you guys, we'll be back on 47. Okay, so we have looked into the relationship from cardinality standpoint. Now we are going to look into the relationship from inheritance standpoint. So the mapping of inheritance between classes could be represented in three different ways in tables. So the one scheme that is probably the most popular scheme is one table for each class hierarchy, meaning every field of every classes in the hierarchy will be represented in a single table. The second scheme is one table for each subclass, and then the last one is a concrete class implementation. So third scheme is rarely used, so we're going to mostly focus on the first and second. Okay, so we are going to actually look into these things using examples, these are the things that you can choose. These are strategies you can choose, and each strategy has different costs and benefits. So the example classes we are going to use for our hands-on lab is these classes. One is a book class. This is the parent class. Book class has title and artist and purchase date and cost and things like that. And special edition book has special edition book is a child class of book class. It will extend book class, and it has a new features property. And international book is a child class of book class. So the book class has two child classes. One is a special edition book, and the other one is the international book. Okay, so international book has two extra fields, languages and region, and the special edition has new features. Okay, but they all share the parent classes properties like title, artist, purchase date, and cost and ID, of course. So these are example class hierarchy we are going to use. Okay, so let's look into first the scheme, one table for class hierarchy. So in this scheme, a single table is used for the whole class hierarchy, meaning the table, that single table contains fields of all classes. Meaning in our cases, it will have ID, title, artist, purchase date, and cost, and special features, and languages and region. Okay, so every field of every class in this hierarchy will be represented in a single table. Now, there is what is called the discriminator column. This column actually indicates which the type, that particular row of the table represents. Okay, so the column indicates which type or subtype a row belongs to. Okay, so it will say something like book, or special edition book, or international book. Okay. Advantages of this approach is that it offers the best performance even for deep hierarchical structure, since a single select may suffice. Okay, you don't have to do any joining, anything like that, so it's actually providing the best performance. The downside of this approach is that changes to any class in the hierarchy requires a change in the table, and also there could be wasted space. Okay, because a single table might in fact have columns that are not being filled. Okay, so we'll look into that using an example. Okay, so how you're going to actually use this particular scheme. So you are going to use a subclass element and extends and discriminator value attribute. Okay, so example is like this. So here we have a book class, and this discriminator value is basically the book. Okay, so whenever there is an entry representing this parent object, it will have book. Okay, and then we have ID, and then we have properties, and then parent class mapping file specifies the discriminator column. So the discriminator column, this is the column under which the value of this column represents which type that particular row represents. Okay. Okay, and this is the child class. So in the child class, the special edition book mapping file, this is a subclass, and it does say extends book, And then this is the discriminator value. So the value that represent a row of this type is going to have a special edition book. Okay. Same thing for international book. In this case, it extends book, and discriminator value is international book. Okay. So when you do the hands-on lab, try to change these values and see how it actually gets represented. So here, this is the result when you run the application. So we have a single table that represents all the fields of the all three classes. Okay, so these are from parent class. So all the entries should actually have values of this. Okay. However, depending on in this case, so this is a parent class entry, and this one is a special edition book, and this is the international book. So these are so this is a discriminator column name. So that is actually specified in the parent class, this book type. Okay, and the values of each discriminator value. So meaning that under this column, this book, and then special edition book, and the international book. These values are gonna be the values that you are going to see here. Okay, and you can see there are a bunch of the spaces that are not being used. Okay, so one downside, as I mentioned before, is a wasted space. Okay, all right. So that is a single table for the class hierarchy. So this one, the second scheme is one table for subclass. What it means is that if you happen to have three classes, in this case parent class, or book class, and then we have two subclasses, right? So in this case, there will be three tables. One table for the parent, and one table for special edition book, and the third table, second table for special edition book, and third table for the international books. So in this case, yeah, so that's basically what I said. One table for each class in the hierarchy. So the common fields, in this case, a parent class, are maintained in the parent table. Okay, and the subclass table only maintain the subclass specific fields. So the international book table will have a single field of features. Is that right? Okay, so depending on the structure, yeah, I'm sorry. The special edition book table will have this column only, a new fields features column. International book will have two columns, languages and region. Okay. So we are going to see the result when you do the hands-on lab. So the now the subclass table should have a foreign key column pointing to this common parent table. Okay. So and advantages of this is that does not require complex changes to the schema when a class is modified. So the basically advantages and disadvantage of this scheme is actually opposite of the first scheme we have seen. In the first scheme, whenever you make a small change in any class, it will force a change for the whole table, right? In this case, if you make a change in a subclass, and then the change will be confined to that particular subclass table. Okay. And it works well with a shallow hierarchy. The disadvantage is that this will result in poor performance because there are multiple tables. It might actually result in query operation might actually perform various forms of joins, and joins is pretty expensive operation to the relational database. So the way you specify join subclass is using join subclass element and using extends attribute. Okay, so this is the parent class. So you don't have to actually specify anything here. Okay, nothing fancy here. And now the child class, we are going to use a join subclass. Okay, so the parent class, you don't have to do anything because parent class will have a parent, it will have entries representing all these properties. Okay, and the join class, the subclass will have a join subclass. And then it does have a new features property only. Okay, and so this is for special edition book, and this is for international book mapping file. Okay, so the result is something like this. So this is a parent table, so it will have the fields relevant only to the parent class, which is a book: ID, title, artist, and purchase date and cost. So these are all common fields regardless of which subclass it represents. And then we have a second table called the special edition book, and it does have only new features. Okay, and then it should actually have reflection. It should have the ID field representing this guy, and then international book we have ID field representing this guy. Okay, so you can think of this guy as actually the foreign key field mapping to the ID of the parent table. I'm going to skip one table for concrete class because it's really not used. Okay, so I'm going to move forward. All right, so let's do exercise 4. So we're gonna do exercise just the first and second scheme. Okay. So we're gonna do just the first and second scheme. So again, if you run the application, a single table. So if you run this guy, so this is the one. Okay, if you run this application. And you can see we have a single table, okay, and then we have a discriminator column of book type, and these are the values that are representing which type this row belongs to. And any spaces that is not used, those are wasted spaces. Okay. And as for subclass, this is the second one. If you run this guy, we have 3 tables. Okay, so this is the book, and this is a special edition book, and this is the international book. Okay, so that is pretty much it. And let me just